We will be, yes, Rahman, assalamu alaikum to you as well. We will be starting off with this presentation. All right, it's a good suggestion. Thank you. This is the code that we'll be using, PRHDK. PRHDK, please join on to this one. I'll send everyone on chat as well. You go to the website, nearpod.com. And the password is PRHDK. So let's start the session. Okay, let's see how many participants do we have. All right, Badr has joined us as well. Nadir. So please log on to the website. We have got 5 participants. Excellent job. Let me add with Nadir as well. Those who have just recently joined in, please log on to the website nearpod.com and use the code PRHDK. Out of 15 people, we have about 17. Abdurrahman Adam is here, Abdul Majid, Yad, Yas, Muhammad Al-Harbi, Muayyad, Rayan. Okay, good. Rest of the boys, please join as soon as possible so we can start the session. Yes, Nadir, let me give you the mic.
Teacher, where is the link for Nearpod?
The link is nearpod.com. Check your chat, and the code is PRHDK.
Teacher, there is nothing in chat.
On the Nearpod, you'll see the option of the students. You have to join as a student. They will ask you for a code. You have to put the code there.
Okay.
All right.
Okay.
Good. So, Abdurrahman, yes, you can go, and yes, you can open Safari as well. That's true. So use your browsers, and we'll start the session in 1 more minute. We have about 11 boys out of 16. So come on, the 5 ones are Nasir. I don't see Nasir here. Sultan, Raji, please join. Muhammad Abu Judail. And Muhammad Al-Dijari. This is a difficult name for me to remember, to pronounce it. Okay, let's see, Muhammad is here or not? Okay, Muhammad is here, sorry. Who's Bromaster? Okay, Scuffed Potato, mashallah. Malaika, good. So 11. Anybody else who is unable to join? And remember, if you guys are not going to be on Nearpod, you might not be marked as present as well. So the administration is, they are trying to be more strict about it, that you guys have to. Jedial, let me send you the link again. I'm sending it to everyone, but okay. Rahman, Wahib, Alam, Abdul Malik. I don't see the name Abdul Malik. Do we have Abdul Malik here? Nope. Anabolic, please join us. Anabolic, Lafani, okay, and we have Badr, and we have Badr, no Badr as well. Good, good, Abdul very good. So we'll start in a minute because it's been already 5 minutes. Come on, boys, let's log in. We have 13, and Badr is still not there. Badr, please log in to the website. And Faisal is here, Iyad is here, Muhammad Al-Harbi, good. Muhammad is here, Muhammad Nadir. I don't see Nadir. Nadir is, did you open the website? Nadir, okay. Please keep the webcams off so we can have maximum speed for this website. Yes, Bassam is here. Yes, please log on to the website dearpod.com. So let's start the session. Okay. The enzymes, we have already discussed about the enzymes, that they are living catalysts. They have the ability to speed up a chemical reaction, right? So we will be, discussing this in the next lesson as well next week. So we'll have a small introduction based on this one. So those who just joined in, Hussam, and there was another student, I forgot the name. Please join the uh, link. We are on dearpod.com. The code is PRHDK. Okay, so what are we going to learn today? Who's going to read that for me? What are the learning objectives? What are we going to discuss today? Okay, Waleed is doing it. Good job, Waleed. You have the mic.
Hello, Mr. Can you hear me?
Yes, I can hear you.
Learning objectives. At the end of this activity, you should be able to explain how the shape of the enzyme and its active site determines its interaction with specific molecules, state how cofactors and enzymes affect enzyme function, discuss how enzyme activity can be enhanced or inhibited by allosteric binding, and analyze data to identify how molecular interactions and environment affect enzyme structure and function.
All right, good job. So let me explain a little bit. The first objective is we should be able to know what is an active site. An enzyme has an active site and how it can, connect with the other molecules with a specific shape, right? Number two, cofactors. Cofactors means those who will help them to do their job. Abdul Malik, you'll have to open a browser, Safari or Google Chrome, and then write down the website, which is nearpod.com. Let me send you the link. And then once you enter in it, it will ask you that if you want to join as a student, you have to put the code. And the code is PRHDK, right? So the cofactors which are supporting the enzyme to do their job, and coenzymes. The cofactors like the temperature and the pH, which is going to help the enzyme do its job. And cofactors like there are inhibitors, blockers, which will stop him to do their job. So they are called cofactors and coenzymes. Number three is how an enzyme can be enhanced, activity can be enhanced. How can we make its performance go faster or slower, right? And number four is analyze data to identify that how molecular interactions. So we're going to look into the data, and then we're going to see that the environment has an effect on enzyme, or yes or no, if it's true or if it's not true. So we will be looking at this. You will be able to analyze the data. Let's begin the lesson, inshallah. Which enzyme makes up the most abundant protein on the earth? Anybody would like to make a guess? There's an enzyme which is widely abundant, has the biggest number of protein on earth. Wow. We're talking about the proteins, not lipids. Iyad. Yes, you have the mic.
Oxygen?
We are talking about protein. Oxygen is an element. Protein is made up of carbon, hydrogen, nitrogen, oxygen. So think about the enzyme. And if you would talk about the gases, the most abundant element, it's nitrogen. It's 78%. So oxygen is only 21%. Carbohydrates, no, carbohydrates is food. Iyad, amino acid makes the protein. And Nader says the sun is not a protein. Sun is the source of energy for us. We have to trap that energy into food, and then we enjoy that energy. So enzyme, we have enzymes in our body, which is helping us to digest the food. There's an enzyme which helps us to grow our hair, skin, and it helps us to make the food, photosynthesis. So which one do you think is the most abundant? Hydrogen is a gas, carbohydrate is a kind of a food. So you're talking about enzyme in proteins. Is it the protein which is doing the photosynthesis? Number option one. Is it the protein that is helping us digest food? Number three. Is it the protein that is making us grow our hair? So choose one of these three options. And Ghazi, you just came in. Please join the website, nearpod.com, and click on to the code PRHDK. Yes, boys. Nobody? Okay, let's look into it. So let's start. Which enzyme makes up the most abundant protein on Earth? You can put up your answers now. I've given you a hint. Choose the three. Either the protein which is doing photosynthesis, which is grabbing the energy from the sun and making glucose for us. Is this the most abundant? Number two, the protein which is digesting the food inside our stomach. Number three, the proteins which is help us growing our hair. So which one is more abundant? What do you guys think? And remember, this is not a quiz, it's just an activity so that I can understand that how much have you guys learned. Okay, so feel free to write down your answers. You have 2 minutes to do this activity. Okay, Muhammad Al-Arbi, you have to mention what I just said, because it's not the first one you said. Okay, protein in food. Muhammad Al-Harbi, you are right, but you have to explain it. Rubisco, oh, you guys are reading ahead of me. Protein in our body. Okay. One last minute. We are waiting for the answers. Okay, Muhammad Al-Samri, he wrote no answer. Okay, protein food. 56, last 30 seconds. Go to the body. Rubisco, anybody who wrote Rubisco, would you like to explain what is Rubisco? Okay, we have Hussam and Muayyad and Riyad and Al Harbi. So let's see, their hands are up. Okay, yes. What is a Rubisco?
What does Rubisco mean?
Yes. What does it do?
What does it do?
Yes.
It is responsible for most of the major global carbon fiction.
Global carbon.
Global carbon fixation. Fixation.
You can't read it even right.
Huh?
Fixation. Fixation. It is fixing the carbon. Fixing, the one who fixes it, we call it fixation. So good answer. Thank you for reading it out for us. Look at this. Did you suggest Rubisco? Then he says, if we go to the Rubisco, here's the definition of it, that it is the one which is actually fixing the carbon into, catalyzes the first step into photosynthesis. So I'll make it very simple for you guys that it is something, a protein which is involved in photosynthesis. That is the most abundant protein enzyme for us because the sunlight is providing us the energy, and the only organism that can capture that energy is the plants. They are the primary producers. So when it comes to the primary producers, it is actually the job of the plants to grab the energy and give us the food. And the protein involved in doing this is Rubisco. So good job. Let's see who would like to read this slide for me. Let's see hands, boys. All right, good job, Walid. You have the mic.
Hello, Mr. Hello, Mr. Can you
Yes,
hear me?
hello. Yeah, you can all hear you.
Okay. Enzymes may be involved in
Anabolic
anabolic
or
or catabolic reactions.
metabolic.
Substance molecules substrate molecules interactive site enzyme. Anabolic reaction occurs in active site. Enzyme substrate complex. Product molecules leaves active site enzyme. Protein synthesis and photosynthesis provide examples of anabolic reaction where small substrate molecules are combined from larger products. Such metabolic reactions are found in processes such as digestion and cellular respiration, where larger molecules are broken down to smaller products.
All right, good job, Walid. Walid mentioned that there are two kinds of reactions happening. One is called anabolic, and the other one is called catabolic. You can say one is constructive and the other one is destructive. This one is making big molecules, this one makes small molecules. So look at this, I have small molecules coming in, and once they are joined, they are released as big molecule. So what is this, anabolic or catabolic? This is anabolic. Yes, we have chat. Yes, Muhammad Al-Harbi, please take it fast. So we have this as a anabolic reaction. I have two small molecules, join them, make a big molecule. From small to big. It's called anabolic. And if I go in this direction, if I go the opposite way, let me grab the right, let's say this is always going right, no left. That's sad. Okay, if it goes in this direction, if I have big molecule and I'm breaking down into small, then this is called catabolic. So this is anabolic when you're going from right to left. No, sorry, from left to right. And the opposite is catabolic. Okay, so any questions about this? Anybody who's not clear about this? Okay, good. We don't have any questions. So let's see. We are going to have a quiz. You have some questions in front of you. I'll pause the screen. Is anybody there with me in the class? Except for Walid and Iyas? Anybody else? So you have a question in front of you. There are 3 questions. Rubisco is an enzyme involved in what? Light-dependent pathway of photosynthesis, light-independent. So there are 2 kinds of photosynthesis, one which needs the light and which one doesn't. So I'll give you a hint, we need the light. So what would be the option? You have like 2 minutes to complete this activity. Okay, we have Iyas finished already. Abdurrahman has finished as well. Okay, all right. So the first option is light dependent. We depend on the light to do their job. Okay, so the first option was A. If we go to the second option, the second question is asking you what is an enzyme. We have to play the video for an explanation. So let me show you this video. We'll play the video and then we'll see what is the question. Sorry, I think I forgot to turn on the voice. Let me turn it on again. Okay, let's play it now. Can you hear the voice now, boys?
Hi, I'm Zershen, and this is the first checkpoint of the Enzyme lecture series. Enzymes are essential to every living organism because almost all functions of our body are only able to occur due to enzymatic activity and reactions. You might not be able to see enzymes with your own eye, or both your eyes, but they are truly exciting things to learn about. And before starting on the nitty-gritty, it is important that we understand what exactly is an enzyme. Enzymes are actually a special type of proteins. Special because they increase the rate of a reaction, and they do so by providing an alternative reaction pathway which requires less energy, thus making the reaction more likely to occur. If that sounds familiar to you from chemistry, yes, enzymes are catalysts. These reactions that we are talking about are metabolic reactions in living organisms. A simple example would be the breaking down of glucose to release useful energy. Do you think that glucose just decomposes and gives you energy? No, of course not. We need enzymes to make these reactions fast enough to derive anything useful. That's why the lecturers at Open Lectures can make lectures. So we must be really grateful for enzymes. Thank you, God of Enzymes. Now, since it's only a catalyst, by definition, only the substrates are affected during a reaction. The enzymes remain the same before and after the reaction, just like how a pair of scissors remains unaffected after being used to cut paper, or how a hole puncher does not become less of a hole puncher after punching holes in your paper. Thus, the enzyme is chemically unaltered after a reaction and can be reused. This means that we don't need a lot of a specific type of enzyme. We don't need so many pairs of scissors. We don't need so many hole punches. However, we do need many types of enzymes for the numerous biological reactions that take place in a living organism. So now that you understand the basics of what constitutes an enzyme and why it is vital to living organisms, we will now look at the 4 main properties of enzymes.
All right, so we have taken the video. Here comes the questions. How are enzymes useful? So you guys, you have to collaborate with a partner, or you could discuss, so not over the chat, but let's see, you have to collaborate on your answers on your own. Don't use the partner. So let me just go back to activate. Yes, you can give a specific example of how an enzyme is useful to a living organism. So one example is enough. that the enzymes are there to do their job, to make the chemical reactions go faster. What kind of chemical reactions are happening in our body? We are breaking down the glucose. Yes, is the waiting room. Okay, so our bodies, we are doing the chemical reactions of breaking down the glucose while we are respiring, and that glucose is giving us the energy. So let's see, let me pause that video, or okay, good answer, yeah, excellent. Yes, Mohammed, the video is paused. Now we are looking into this. We have 3 responses. Yes, that is true, but which example would you like to highlight? Makes the chemical reaction faster, but how can we, which one of these? You have to set an example. You boys are talking in general where we have to give a specific example. If you guys are going to, put down simple answers like that, then I'm afraid you won't be able to get good marks out of it, right? Since you're all taking the IGCSE exams. And what is this? And who is this? Yes, you have to be a little bit more serious about this. And Muhammad says healthy, but you're not listening to the question. How an enzyme is useful to a living organism? An example of it. The Yusuf again, no marks for this. Harbi, I don't think so. It breaks down the beat. Where? You have to be again specific about it. Yeah, you are doing a good job. You can say that it is helping us to digest the proteins in our stomach, in our digestive system. Yes, the enzymes are working there. So you can say that, one example, good. Anybody else who can give an example? Out of 20 boys, we have 1, 2, 3, 4, 5, 6, 7, 8, 8 boys responding. So the scores is going to be for 8 boys. What about the rest of the 12? And we have, okay, the whole class is here, good. But very little participation. Okay, we have Ghazi. Ghazi, again, this one is in general. Building muscles, destroying toxins, and breaking down food. Mayan, excellent answer. Yeah, okay. They are made out of catalyst. They are the catalyst. Destroy toxin, good. Muhammad Al-Hadi says a picture. Let's see the picture. Somehow the whole products use enzymes to speed up chemical reactions in this, and this is copy paste. Good. Anyway, I like it. They are made out of catalyst. Yeah, they are catalyst, living catalyst. Okay, good job. So we have two more answers. We can enzymes create chemical reactions. Yes, which one? Example. Lipase, they are found, okay, good. Yes, so they are involved in digesting the fats. So Abdullah Imani, okay, good job. So all of you have done it right, mashallah. Let's go to the next slide. Good job. So you all have a good example in your mind of what is an enzyme. So if you're looking at the enzyme, it has the ability to reduce the energy needed for a chemical reaction. For example, a chemical reaction might take place at 100 degrees Celsius, right? 100 degrees Celsius. But our bodies cannot go to 100 degrees Celsius. What's going to happen? If I take my body to 100 degrees Celsius, I'm going to die straight away after a minute or 2 minutes. So what does the enzyme do? They reduce the energy that is needed for chemical reaction, and then they will let it go fast. Right? Look at this. This was the blue level. This is where we wanted the chemical reaction to take place. But enzyme lowers it down and brings it to this point, and then the chemical reaction is happening. Okay, Nader. All right. So let's go to the next slide. Okay, we have a quiz. So let me just open up the quiz according to your views. I'm switching to a student view. All right, there are two questions. Enzymes catalyze reactions by lowering the activation energy needed for the reaction or increasing the activation energy. What does the enzyme do? Did it lower the energy needed or did it increase the energy needed? So this is the question one. And I have explained it. And this is lowering. Boys, please keep the webcams off. And the second one is are usually proteins, right? And this is the 3D structure. During protein synthesis, peptide bonds are formed. Okay, a ribosome is present. So you can see these lines which are connecting with each other. They are known as like a peptide bond. So a ribozyme, sorry, present in the large amount of the subunit of ribosome is responsible for making these bonds. So let's see what is the question two. Salivary amylase is a protein. We have amylase in our mouth, which helps us to identify the taste, especially the sweet. If we are eating something sweet, we are able to digest that sweet in our mouth with the help of amylase. Amylase is an example of an enzyme. This is an enzyme. Where is it? It is in our mouth. Okay, so let's go to the next slide. Here is the quiz. Two questions again. I didn't get the second question for the last one. Let me check. So you have got two questions, boys. Try to watch this. Let me see the previous. So boys, start the quiz. I'll pause the screen. Good. And the previous quiz, okay, we have 10 people having correct answers. Most of us didn't even try. Okay, no problem. Okay. So we have Iyad who answered one right and one wrong. Okay. Okay, Abdul Majid, no. Okay, let me see the question for you. So I'll, answer with you. The question is, which molecule is the substrate for salivary amylase? Now, substrate means that amylase is going to work on. So I told you that it has to be something sweet. We cannot digest cellulose. Phospholipid is in the cell membrane. Protein is something else. Starch is the answer. So the molecule where the salivary amylase can work on is actually starch. Let's go to the next question. Identify the products of the reaction between salivary amylase and it's not going to make amino acid. This is proteins, fatty acids, it's lipids. It could be maltose, it could be sucrose. So you guys can make an option over here. But choose between C and D. Maltose and sucrose. Sucrose is the sugar. And maltose is also a kind of sugar which is available in D. So let's choose this one. And let me go back to the teacher's view. Let me see how are the results. Okay, he has got them both right, mashallah. Excellent job, as you can see on my screen. And Abdurrahman, better luck next time. Waleed Harbi did it both right, mashallah. Iyad, excellent. Abdul Majid, better luck next time. Muayyad, we are still waiting for your second answer. Muhammad, good, at least you got one right. Muhammad, yes, you got both right. Good. Yusuf, no answer. Faisal, no answer. Sultan, no reply. Muhammad, better luck next time. Hassan and Ryan. So, okay. Abdullah Yamani, good. You got one right. Ghazi and Sharif, excellent. You've got two rights. And Abdurrahman Al Alim, all right. So, no problem. Try to see the right answers, and then we'll, inshallah, be able to do better next time. So, let's go to the animation. Look at the animation, how an enzyme reacts with a substrate to create products. They come in, they're not exactly the same shape, but it is actually changing a little bit of its shape so that it can accept it. Right? This is called induced what? Induced theory. What was it? I just slipped out of my mind. So just look at it. They have a lock and key structure. They come in, they fix it, and then they are able to create the products. So we will be stopping here today. We will be continuing from slide 21 for you guys. And we will complete this session in the next class, inshallah. So if there are any questions, please let me know. Raise your hands. I can give you the mic. Muhammad is raising a hand. Yes, Muhammad. I'll give you the mic. Yes.
Hello, Mr. How are you?
I'm good. How are you?
Alhamdulillah, good. Mister, can you give me more time to do the homework?
All right. Which homework are we talking about?